Here's a set of problems out of the book that may or may not look familiar to you. But essentially what it was they took one equation, which was 3x minus 10. So it was the equation 3x minus 10, and they wanted you to substitute in four different numbers for x. And they split that up into four different problems. They said in the first problem, put a 0 in for x, and what do you get? You get negative 10, 0 minus 10. In the second one, they said put 20 in for x. And what do you get? You get 60 minus 10, which is 50, so on and so forth. Well, there's a whole other way you can represent this exact same thing, and it would all be in one problem, and it's called an input-output table. Input-output table. Input, output, table. So now I'm going to show you what that looks like. An input-output table is an X and a Y column. So I'll use the same example I just showed you. For my X column, we're going to use the values 0, 20, negative 2, and 2/3. And we want to know what those will give us if we substitute those into the equation 3x minus 10. So if we substitute a 0 into there, 3 times 0 is 0, 0 minus 10 is negative 10. So when we put a 0 into our equation or function, you should say, or I should say, is negative 10. When we put a 20 in there, like I said before, 60 minus 10 is 50. If we put a negative 2 in there, we get 3 times negative 2, which is negative 6, and negative 6 minus 10 is negative 16. And if we put a 2/3 in there, 2/3 times 3 is just 2, because the 3's will cancel out. 3 times 2/3 is basically 6 over 3, which is 2. Or you could say the 3's cancel out and you're just left with 2 minus 10, which is negative 8. So this would be negative 8. All right, so an input-output table is just combining a bunch of problems into one, basically. So that page that I showed you before, the page 259, they split it up into four separate problems. Now it's all combined into one problem. Do these four things for this one problem. All right, so that's part of the work for today. The first set, I think it's page, 25 or something? Let me see here. Now, page 50, number 23 and 24, they say create an input-output table, and they give you the values that they want you to use for X. So you're going to have to draw this table just like I did, put those values in for X that they tell you to use in those two problems, and then sub them in one at a time into the equation and fill in the Y column, the output column. The X is the input column. That's the number you're inputting, that you're putting in to the equation or to the function. Y is the output column. That's the number you get out of this equation once you put that into it. Okay, input-output table, XY table. There you go. You already kind of knew how to do that. You just maybe didn't know what it was called, or that you could represent it like it did on page 259 in four separate problems, or in one same problem. Okay, there's really nothing else new to show you except to practice inputting into some more difficult equations, namely ones that have square roots in them. So let's say we have the function square root of x plus 3, and they want you to evaluate that for 16. That means you have to substitute 16 into the function. So you do that. The square root of 16 plus 3. Your answer is not 19. Don't ignore the square root symbol. You have to take the square root of 16. So in case you forgot, a square root is the opposite of an exponent raised to the second power. So for example, let's start with the number 4. If you square 4, 4 squared is 16. And if you take the square root of 16, you're back to 4. You're back to where you started. So let's say you have a problem that looks like this. 4 squared inside of a square root. You would square 4, which would be 16, and the square root of 16 is 4. So they cancel each other out. A square root and a square symbol cancel each other out, and you're right back to where you started. It's kind of like addition and subtraction. Let's say you start out with the number 4 and you add 3 to it, and then you subtract 3. You're right back where you started. Adding and subtracting cancel each other out. Multiplying and dividing cancel each other out. Squares and square roots cancel each other out. So you guys know how to square things, and I'm sure you know how to square root things, but just for a little reminder, that's how you do it. It's the opposite. It's what number do you multiply twice in a row to give that. So here's a little cheat for you. If you look at a times table, the numbers on the diagonal are all your perfect squares. They're all the ones that you could take a square root, and it's a whole number. You could say, here's your times table. Actually, I have one on the wall. I'm going to rip it off the wall and show it to you. Here's my times table that I just tore off the wall. Let me erase this so you can see it better. That's annoying. I'm just going to turn that off. There we go. All right. Here's my beautiful times table that's been on the wall forever. Just got violently torn off its home. Times table, the diagonal, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, so on and so forth. I already circled the diagonal in a big oval that I just called a circle. All these numbers on the diagonal are called perfect squares. They all have a whole number as their square root. The square root of 9 is 3. 3 times 3 is 9. See what I mean about working backwards? What's the square root of 36? What number multiplies twice in a row to give 36? 6. 6 squared is 36. Square root of 36 is 6. You're back to where you started. All right, so there's your quick little refresher on how to take square roots. And the second set of problems, well, I erased that one I was doing up on the board, but I think it was square root of 16 plus, I don't even remember what I wrote. We'll just say 3. That'd be 4 plus 3, which is 7. You get that? Good. I turned the light off. It didn't even work. It was square root of 16 plus something. We'll say 3. Square root of 16 is 4. 4 plus 3 is 7. So the answer to that would evaluate the function at 16. If it was square root of x plus 3, your answer would be 7 for that problem. Right, so that's the second half of the problems that you have to do today. It's not going to have to be a table. You're not going to have to substitute in more than one number into the equation. So that's good. Every problem is just one problem, but they all have square roots in it. So it'll give you some practice at square roots. So have fun with that.